So we talked about the difference between continuous and discrete. Continuous, remember, is something that you measure. Discrete is something that you count. So in this chapter specifically, we're going to learn two types of discrete variables and how to find the probability of discrete events happening. And this is going to help us answer the question of, like on the last unit, whenever it said, like, what is the probability that exactly one light bulb is defective? Remember, we had to, like, list out all of the possible scenarios and add up the probabilities. Well, something I didn't tell you is that there's a really easy calculator trick that we can do, and we're going to learn it. Yeah. So I showed you the long way, but, like, what if it said, what's the probability of exactly 5 out of 50 light bulbs being defective? Well, it's almost impossible to list out every combination of 5. Like the first one, the 7th one, the 8th one is defective. Like that would just be impossible. So our handy dandy calculator is going to help us with that. And that's what I mean by probability of discrete. So like counting, like what is the probability that 5 out of 50 light bulbs is defective? So that's what our calculator is going to help us with. A probability distribution is a model that describes a long-run behavior of a variable. So in Wolf City, and this is a fictional place if any of you were worried, it is fictional. There's really no such thing as Wolf City.
Why did you conclude it's a fictional place?
I don't know. It is a fictional place. Just going to throw that out there.
Someone be afraid?
Regulations prohibit no more than 5 dogs or cats per household. Probably shouldn't have more than that anyway. Let X equal the number of dogs or cats per household. Is this variable discrete or continuous?
Discrete.
Discrete. Hey, put your laptop away.
There is a Wolf City, Texas, though.
Put it away.
That was a false statement.
It's a fictional place. This is a fictional one, not the real one. I don't want to give any false information. Like that Wolf City probably allows more than 5 dogs or cats per household, but this Wolf City does not. So I don't want you to confuse the two.
Thank you for that clarification.
Yes.
Very
Yes, I know.
It's probably not going to be as good as
So is this variable discrete or continuous? It is discrete. Why is it discrete?
Because you're counting.
You're counting the number of dogs or
You can't
cats.
have half a cat. And if you do,
can't.
that's
Or
gross.
can you if you...
You can
No.
break the dogs and cats down.
No, you cannot break dogs and cats down.
Wait,
Okay.
Wait, 5? Would that be open?
No. What are the possible values of how many dogs or cats you could have starting from least to greatest?
Possible values. Like
Possible-
5, 4,
0 through 5.
0 through 5, right? I could have 0 dogs and cats. I could have 1 dog or cat. I could have 2, 3, 4, 5. So my possible values of results could be 0 through 5. The Department of Animal Control has collected data over the course of several years. They have estimated the long-run probabilities for the values. So they have calculated these probabilities in the long run, so probably over several years, and here's the probability distribution that they have given us. What is something that you notice about all the probabilities? What would they add up to? 1. So since I have listed out this sample space, or all of the possible outcomes, it should add up to 100%. So they add up to 100. This is called a discrete probability distribution. It can be displayed in a histogram with the probabilities on a vertical axis, if you were wondering. So here's what it would look like. What kind of shape is that?
Right.
Right skew.
Right skew. Good. So discrete probability distributions gives the probabilities. It is always in the long run, so that means that the data that they collected has been over a lengthy amount of time. It's been in the long run. It's not like they took one sample and they said, here is the probability. They would have to do it over the course of a long time. We haven't really justified like what is a long time and what isn't, but for now, we just accept the fact that it is the long run probability. Usually displayed in a table, but it can be displayed in a histogram or formula. We really only see it as a table in this class. Remember that probabilities are always a number between 0 and 1, inclusive, and then all of the probabilities add up to 1. So when you're looking at a probability distribution, those are the two things that you're looking for. Sometimes multiple choice questions give you something where they say, like, what is wrong with this table, or interpret it, and you have to say, well, it wouldn't be correct because one of the probabilities is over 1. Or probabilities don't add up to 100%. So those are like the two things that you're looking for when you're looking at a table. So based off of this, you can answer questions such as, what is the probability that a randomly selected household has at most 2 pets? So what would that look like if I were to write a probability statement if it's at most 2 pets? So it'd be the probability that X is what? If it's at most 2.
Less than or equal to 2.
Yeah, 0, 1, and 2. So it would be X is less than or equal to 2. You're going to add the numbers together. So 0.26 plus 0.31 plus 0.21 is 0.78. Good. So what I would look for, like maybe let's say this were a free response question, I'd be looking for the probability statement, which is this, and I would be looking for the number. You could even show your work as far as adding those together. AP graders are always looking for work. So if you just put 0.78, if it were correct, you might get full credit. But let's say that you were wrong, but you still put the right probability statement, you could get partial credit for that. Those are just things to think about. What is the probability that a randomly selected household has less than 2? So what's different between at most 2 and less than 2?
It doesn't.
Not equal to.
Yeah, it doesn't include 2. So it's just a less than 2. And so I would only add 0 and 1. Notice that this probability does not include 2. So only 0.57. What is the probability that a randomly selected household has more than 1, but no more than 4? So what numbers do those include?
Greater than 1, less than equal to 4.
Good. Greater than 1, less than or equal to 4. So it's going to include 2, 3, and 4. Not include 1 because it says more than 1. So when calculating probabilities for discrete random variables, you must pay close attention to whether you are inclusive of that number or not inclusive of that number. So like more than, less than, those are not inclusive. Those do not include. But if it says like at least, at most, less than or equal to, greater than or equal to, those will be inclusive. I think we're pretty good at that though. Another thing, looking at a probability distribution, it could ask you to calculate the mean and the standard deviation. And these formulas will be on your formula chart. So next to this slide, I want you to write on formula chart. The mean is just where the probability distribution is centered. Another word for mean in this case is your expected value. So next to mean, I also want you to write expected value. I don't like that I'm using green because it's the same color. So expected value. And they may write it as find the mean. They may say write it as the expected value. Yes?
So when you're looking at a distribution, by center, do you mean center where the most are clumped or the center of the actual number line?
The center where most are clumped.
Okay.
Yes. So another word for mean in this chapter is expected value. And the standard deviation just describes the variability. So basically how the typical distance from the mean. So the formula is the sum of all of your x values times the probability. So I'm going to show you 2 ways to find the mean. You could either do it in your calculator like using 2 lists, or you could do it just by taking your x value times your probability and just adding those all together. And then this is the variance formula. Standard deviation is just the square root. But I'm going to show you how to do that in your calculator. So standard deviation will always be in your calculator using your 2 lists. So you really can't calculate the standard deviation by hand. I mean, you're going to be using your calculator for both mean and standard deviation, but for mean, there's 2 ways. So I'm going to show you both. But for standard deviation, there's really only one way, using 2 lists and doing 1 bar stats. So if it just asks you for the mean, you don't necessarily have to go through the steps of doing list 1, list 2, 1 var stats. But if it asks you for the standard deviation, you do have to go through those steps, unless you're wanting to use the formula, in which case you could. So here is my list again. To find the mean, I'm going to show you the first way without doing the 2 lists. And then I'm going to have you put in the 2 lists and we'll do the mean and the standard deviation together. So if I were just doing it the short way, the mean essentially is taking the sum of your x times your probability, so 0 times 0.26 plus 1 times 0.31 plus 2 times 0.21 plus all the way to 5 times 0.03. So type that in your calculator. You don't even have to do the first one because it's 0. You're taking your x times your probability for each x value. You're adding those all together. And you should get an expected value that will most likely be a decimal. So when someone gets that, tell me what you get. $1.51. Okay, 1.51 pets. Now, does it make sense to have 1.51 pets?
Yes.
No, it doesn't make sense to have half a pet, but when you have expected values, you keep them as a decimal. So even though it doesn't make sense in your head, don't round expected values. So keep as a decimal. Even if it doesn't make sense. Like I think that the average, I get this number wrong every year. I try to give this statistic and it's always wrong, but it makes sense. The average number of people in a household is like 2.41 or something like that. You can't have 0.41 of a person, but if you take the average of every single number of people in a household or family members, then it averages out to be a decimal. So you just keep it as a decimal. Don't round. Even if it doesn't make sense, still keep it as a decimal. So now I'm going to show you how to do it in your calculator. So what I want you to do is put your x values in list 1, and I want you to put your y values in list 2. And then stat, calc, 1 var stats. Okay, so once you do, you go to 1 var stats. So stat, calc, 1. I want you to change, so your list should be L1, but I want you to change your frequency list to L2.
Wow.
So change frequency list to L2, then hit calculate. And you should get that your mean is 1.51 and your standard deviation is 1.3228. Don't do it.
It looks fine when we do it.
Are we good with that?
It's 0. It's because that's 0.
Here's a game.
This game is almost as fun as Statland. It's very close.
Almost.
So,
Wow.
if a player rolls 2 dice and gets a sum of 2 or 12, he wins $20. If he gets a 7, he wins $5. The cost to roll the dice 1 time is $3. Is this game fair?
No.
So, what you have to do in order to decide whether something is fair or not is you have to decide if how much it costs to play the game equals your expected value or your expected winnings. So in order for it to be fair, like the cost needs to equal the expected winnings.
It is fair. So you roll enough to do.
Well, we have to do it mathematically.
You don't gamble at
Technically,
I can
that's
now.
what you get
Think about it.
So I want to decide if whenever I'm playing this game, am I expected to win $3? If it's over that, then I would definitely want to play because I have a higher chance of winning than what I'm getting more output than I am input. But if it's less than that, then the game is not fair and it benefits the people that are in charge of the game or that are playing the game. So that's normally how most games work, especially that claw thing. I don't know if there's any math involved, but it's the
That's not
worst. Right, so what we want to do is we want to create a probability distribution. And in my X's, I want to put my potential or my expected winning. So what are my three options? Like I can either win what, or what?
25 or 30.
25 or negative 3.
So I can either win, not even thinking about the negative 3 right now. Let's just think about, I could either, like when I play the game, I could either win $0, I could win $5,
Wait,
or I could win $20. Like when I play this game, I'm either going to come out with nothing, and then we'll subtract the 3 at the end. I can either come out with nothing, I can come out with $5, I can come out with 20. So now I want to figure out my probabilities, probability of X, and that would represent the probability of winning $0, winning $5, and winning 20. So let's do the 5 and the 20 first, and then we can come back and do the $0 because we can just subtract that from 1. And so it says if he gets a 7, he wins $5. If he gets a sum of 2 or 12, he gets 20. So if we're doing the $20, how many outcomes, because there's 36 total, how many outcomes is it possible for me to get a sum of 2 or a sum of 12?
2 is 1.
2.
2 is 1. 12 is
1, 2.
6, 2, 2, 6,
4 12s.
4.
It's more than 1.
It's more than 1.
It's 1/3.
Should we list all of these out?
Is it 2?
Why is that a 36
Wait.
and not 12 if there's 2 dice and 6?
6.
No, it's 2.
Oh,
You could get 1 and 1, or you could get 6 and 6.
Yeah.
So it's 2 out of 36, or 1 out of 18. Okay, sum of 7. This one might be, if you want to list them out, you can, or we can just think about it. You can get 6, 1.
5, 2.
Just as easy as a 7.
Is that 6? Maybe.
Wait, how do you know if they want the sum if they just want the number 7?
It's impossible.
Okay, so you could get 6, 1, 1, 6, 5, 2, 2, 5, 3, 4, or 4, 3. And so that's how many?
6.
6 out of 36.
Why is it if he gets a 7?
Brooks, the 7 is
Yeah, 7's on. Yes.
How can you have 6, 1, and 1, 6?
Except 2 die in the order.
But not 1, 1, and.
Because he's looking around.
Same number.
It's the same number.
But it's not the same die.
There are not 4 outcomes.
They're both getting the same
There
thing.
aren't 4 outcomes. Does that make sense? There's only 2. 1, 1, and 6, 6. Okay, so then to get 0, it's everything else. And so 36 minus 8 is what? 28 out of 36. If you want to reduce them, if that bothers you, it could be 7 out of 9, 1 6, 1 18. And so that bothers you more. Oh, sorry. Okay, so from that, now I want to figure out what my expected earnings are. So my mean, to do that, I'm going to take 0 times 7/9 plus 5 times 1/6 plus 20 times 1 out of 18. Someone want to do that really quickly?
Yes. How much is the bonus for? 5.
No, make it like 1 out of 20, though 1 out of 25. Like 1 point.
Oh,
So if they missed 1, yeah. Which I think ends up being 4 points.
On your answer on one, it says like
4.9.
the length of the square is 25, but it only asks for the side of the square, and they're all putting side of the square, so is that okay? Because it looks like the answer is 25 on here, but the question only asks for
Is it
the
1.9?
side.
Oh, okay.
Yeah.
That's fine.
Does that make sense?
Yeah.
Sorry.
Okay, so you should get 1.944.
I got 1.94444.
That's awesome. So what that means is I'm only expected to win $1.94, but I'm paying $3.
So it's not.
So I'm actually gonna lose. So if I do 3 minus 1.944, then you get what?
$1.60.
So you're gonna lose $1.60.
You're
Well, it would be minus 3. It's fine. So I'm going to lose $1.60, so no, this is not fair. Bunch of con artists at this game.
I think it would be.
I don't know if it's a car.
If you keep.
Okay, the next thing that we're going to learn now is we're going to separate the discrete distributions into 2 types. So we're going to have like 2 branches. Got a big tree, discrete. We're going to separate it into binomial and into geometric. And the main thing from this chapter is deciding which one to use and when. But I'm going to try and make it as simple as possible so that it'll be easy to do. So the first one we're going to start with is binomial. So suppose we decide to record the gender of the next 25 newborns at a particular hospital. Questions that we could ask in this chapter are, what is the probability that at least 15 are female? What is the chance between 10 and 15 are female? Out of the next 25 newborns, how many can we expect to be female? Those are like types of questions that you'll be asked. And we can use binomial distributions to answer that. Properties. I want you to highlight this slide, circle it, underline it. You need to memorize these properties. The first property is that there is a fixed number. So they're always going to give you a total number of trials. So it'll say, out of 25 newborns, out of 10 light bulbs. So out of 25 babies. Out of 10 light bulbs. Out of 7 cows.
Small tumor sprouts.
Something like that. So they're always going to give you a fixed number. And this is the key difference between binomial and then the one that we're going to learn next, which is geometric. Okay, so those are the main differences. And the number 1, that's how you discern whether it's binomial or geometric. Fixed number.
What were we just doing?
That was just a probability distribution. So that's different. Each trial results in one of 2 mutually exclusive outcomes. So we say success or failure. So by that I mean I have 2 outcomes. Like if I'm doing the gender example, I have 2 outcomes, boy or girl. Success or failure.
Well, wait, which one's the success?
One is a
You-
failure.
You can, yeah.
Females.
Females, success. Outcomes are independent of one another. Therefore, like the probability of having one child, it being a boy or girl, does not determine or change the probability of having a second child, boy or girl. So the probability stays the same with every single trial. Does not change. Yes.
What you said mutually exclusive is dependent.
Right. This is not mutually exclusive.
It said each trial.
Independent is the opposite of mutually exclusive.
No, you know
Wake up.
mutually exclusive.
It says
mutually exclusive is dependent.
So let me explain that. Number 2, it's saying
Yeah.
each trial. So like within that trial, you have 2 outcomes. You either have a boy or you could have a girl. So those 2 things are mutually exclusive within that trial. But then it's saying, like, okay, here's one trial. My second trial, so my second baby, does not depend on the outcome of the first baby. Does that make sense? So that's what it means by being independent. And then the probability is the same. So 3 and 4 go hand in hand. So saying that something's independent means that the probability is the same. Binomial is defined as the number of successes observed when the binomial experiment is performed. When you are listing the number of outcomes, so something I want you to write, when you're listing out possible outcomes, so possible outcomes, they start at 0 and they go to number of trials. So 0 to 25 babies, 0 to 10 light bulbs, 0 to 7 cows. Okay, so it starts at 0. That's another difference between binomial and geometric. It starts at 0 and it goes to the number of trials. Are these binomial? Toss a coin 10 times. Count the number of heads.
Yes.
Yes, because why?
It's out of 10 times.
Out of 10 times. Fixed number of trials. What else?
It's mutually exclusive.
Right. You either get a heads or a tails. And the third one?
Different trials are independent.
Independent. That's awesome. Thank you, Freddie. Deal 10 cards from a shuffled deck. Count the number of red cards.
Too many.
No.
Red, it depends, is it red?
It is not.
Is it red
it's not
versus
the
black?
card.
It's dependent.
It's dependent because why?
You lose red
Because if
cards.
you take a red card.
You're
it's one less
losing red cards, exactly. So I'm not replacing them.
So it's geometric.
No. We haven't learned about that yet. Okay, 2 parents with genes O and A blood types. Count the number of children with blood type O.
Why is that?
It doesn't
Well,
have a
they
fixed
count,
number of trials.
they
No
count either
fixed
O
number
or-
of trials.
Oh, and
It
then-
doesn't say
Count the number of their children or just random children?
their children.
How many children can they have?
Their children.
What would they tell us about
Hi,
that?
it's your child.
That's
Hey,
how
oh.
his brain thinks,
How is it not
though.
a
It's
fixed
like
number?
random children.
Infinite amount of
No, there is no fixed number.
Infinite amount of kids.
Go count other
That's
people's
geometric, is
children.
infinite.
That's impressive.
Yeah.
So it is geometric.
Okay, here is the formula for binomial. You do not have to have this memorized. It is on your formula chart, but I'm going to show you a way in the calculator to do it. The only thing that you would need this for, like this right here, it's at the bottom, is knowing what n and x represent, because sometimes on a multiple choice question on an AP test or just on a test in general, it gives you 4 answer choices in this format, and it says which one of these is the right one. So n is your number of trials. X is like the number that you would put in your probability statement. Like when it said at most 2, then you would put 2 there. So it's like the number of successes, kind of.
What's n of the exclamation mark?
Factorial. So if this were a 5 here, it would be like 5 times 4 times 3 times 2 times 1. You'll never have to calculate this by hand or anything. The only thing you would need to know this for is to be able to recognize it in a multiple choice question and be able to plug in the right values for n and for x.
So you don't even know.
So you're given this on the formula chart.
So you don't even know what an exclamation point is.
Mm-mm. So you're given this on the formula chart. Okay, so let's record the gender of the next 5 newborns. Is this binomial? We said yes. X represents the number of females born out of the next 5 births. So we're going to say that successes are females in this example. And we have 5 trials, 5 children. What are the possible values? Where does it start? I could have, what's
12.5 will be girls.
no, what's the smallest number of girls I could have out of 5? 0.
0, then 1.
0, 1, 2, 3, 4, 5. Yes, it will always include 0. And then it'll always go to the number of trials. Okay, this question, it says, what is the probability that exactly 2 girls will be born out of the next 5 births? So it's the probability that x equals 2. This is the formula, but like I said, you don't have to have that memorized. It is just there to be able to recognize. It would just be in a multiple choice. I'm going to show you in the calculator how to do that. So it says, no, it says exactly 2 out of the next 5 births. It's like that light bulb example. Remember when it said exactly 1 out of 2 light bulbs and we had to think of every single scenario? So in your calculator, also the probability of having a girl and a boy is 50-50. So probability of x is 50%, 0.5. Anytime it's talking about births of children and genders, you assume that it's 0.5. Okay?
Isn't there like thousands of things?
No. Okay, so what you're going to do in your calculator, it will be a, so I'm going to say the probability that x equals 2. You're going to go to second vars, and you're going to scroll down to binom PDF, which is option A, second vars A. So binom PDF,
What does P mean?
PDF, second vars A, binom PDF, parenthesis. And you're going to write this down because this is what would go on a free response part.
Is that what it's supposed to look like?
Yeah. Then it's going to prompt you for trials. The P is probability, and X is the X value, which is the X equals 2. So my trials, how many trials do I have? 5. So I'm going to put a 5.
X value is 2.
My probability is what? 0.5. And my X value is 2. So 5.52, hit paste, and you should get 0.3125. Not normal, binom.
I just did this.
You get to use your calculator always.
You put it inside of this.
So this is what you would put on a free response. You'd put the probability statement, you put what you typed in the calculator, and then you would type in the trials probability number of successes. When it says exactly, you're going to use PDF. And I'm going to show you an example where we're going to use binom CDF here in a minute. So exactly means PDF. I want you to write that down. Exactly,
Something's weird.
meaning like equals, is PDF.
How do I get out of it?
So it says for the next one, what is the probability that less than 2 girls will be born out of the next 5 births? So normally when I answer these questions, I always write out my possible outcomes,
CDF.
and I like to highlight what my range is. So if it said less than 2 girls, it would be the probability that X is less than 2. If X is less than 2, what does that include? 0 and 1. So there are 2 options, and I'm going to show you both of them. You could do binom PDF of 0 plus binom PDF of 1 and add those 2 together. And that takes a little bit more work, but it's also like for sure always going to work. Like if you did binom PDF of 0 successes plus binom PDF of 1 success. You could add those 2 together. So you could do PDF of 1, 0 plus PDF of 1. And that will work. And AP graders will take that and it will work 100% of the time. It's just writing out more. I'm going to show you another way. And if you have an inequality that is less than, greater than, less than or equal to, greater than or equal to. So any inequality that is not equal to, you're going to use binom CDF. Okay, and CDF is always a less than or equal to statement. So when I indicate CDF, and we're going to go to that, so second vars B, binom CDF. I still have 5 trials. I still have 0.5 as my probability. And the number that goes here, this X value, is always the top part of your range. So when I put a 1 here, what that means is that it includes the probability of 1 and everything below that. So I put a 1 here, and I don't put a 2 because I don't want to include 2. So you could even write this as X is less than or equal to 1. You're going to do a 1 minus when it's greater than. So I'll show you that in a minute.
Wait, so this way doesn't
So the number that goes here is always inclusive of that probability and everything below. The biggest mistake I see people make is that they put a 2 here, and then that is wrong because you don't want to include 2. So when you put a CDF, that X value, it includes that probability and everything below. So if you put a 2 here, it would include all of that. But you don't want to. You just want 1 and everything below. So a 1 goes here. So let me say that again because I promise you that's what gets confusing. So everyone just eyes on me for a second. When you do binom CDF, the number that goes here includes that probability. So it includes the probability of 1 and everything below. So it includes the probability of 1 and everything below. You don't put a 2 there, even though I have a 2 here in my probability statement. I don't put a 2 there because I don't want to include it. That is the biggest mistake that I see people make. Yes, Freddie.
Okay, so you said the PDF way always works, and then the CDF way doesn't.
It does always work. It's just when you put the wrong number here that people mess it up. Does that make sense? So sometimes I just see more mistakes made with CDF than with PDF. Does that make sense? Yeah, Reese.
You know, so you can't use this for like if it's like 1, 2, and 3.
I'm going to show you that way too. Yes, Drew. So less than or equal to means that it includes that probability and everything below. But if it's just a less than, like if it's less than 2, you don't want the probability of 2. So saying less than 2 girls technically means less than or equal to 1 girl. So you could write either one of these probability statements for that. So here's the calculator stuff. I kind of already explained that. This right here is the probability distribution. So if I did a binom PDF for 0, 1, 2, 3, 4, and 5, and I wrote them out individually, that's what this would look like. If it's saying what is the mean number of girls, what is that asking me? What's the same thing as mean? Expected value. So like the expected number of girl births. How do I calculate that?
You multiply the x by the probability of each of them happening.
Perfect. So I'm just going to add up all of my probabilities. So x times probability. You could put them in the lists and then do one var stats where list 2 is your frequency.
It's almost not easy.
Something else that you could notice is that it's the same thing as multiplying n times p. So these formulas are the formulas for binomial, mean, and standard deviation. They are on the formula chart. So if I have a binomial distribution and it asks for the mean, I just take my number of trials times my probability. If it asks for the standard deviation, I take my number of trials times my probability times 1 minus my probability. You don't have to memorize these. You just have to know when to use them, okay?
So what's the top one? Binomial?
Binomial, yeah.
So binomial going to be the same probability for all of them? Okay.
It'll give you the probability in a binomial. It'll either be 0.5 because that's what we assume, or it'll give you the probability.
So when would it say? Just ask you for the standard deviation of binomial?
It'll just flat out ask you for the mean and the standard deviation. So mean and standard deviation, you would get 2.5 and then 1.118.
I knew you could 2.5 girls.
Okay. Here's another example. It says, in a certain county, 30% of the voters are Republican. If 10 voters are selected at random, so there's my fixed number of trials, what is the probability that no more than 6 of them will be Republican? Okay, so there's a lot of information here. We need to dissect it. So 10 is my number of trials. 30% is my probability. So I've got my N and I've got my P. And it wants me to find the probability that no more than 6 of them will be Republican. So you can do a couple things. You can list out all of your outcomes. If it's saying no more than 6, what numbers am I wanting to include?
6 and below.
6 and below, right? So I want to include 6 and I want to include everything below that. So 6, 5, 4, 3, 2, 1, 0. That's why sometimes doing the binom PDF doesn't work, because I would have to do it 7 times, which seems like a lot. That's why I like to do CDF. So my probability statement would be the probability that x is less than or equal to 6. So I'm going to do a binom CDF. How many trials do I have? My probability is 0.3, and my number of trials is 6. Another thing that free responses like you to do is define your distribution. So I would say it's a binomial distribution. Ugh, cannot write. Binomial distribution, n equals 10, p equals 0.3. So you should get, when you type this in, 0.9894. Go out 4 decimal places for these questions. Mm-hmm.
When we did the first problem on this page before the formulas,
Mm-hmm.
why did we use the different way of finding the mean? Because it's binomial. We didn't just add.
Because it was binomial,
That's
yes.
just for the probability.
The adding works for both, but this is the n times p is just a shortcut if you don't want to add.
I did the multiplying though, and I didn't get.
You should still get 2.5.
Oh, I did get that. I saw the number. So it works.
What is the probability that at least 7 are not Republicans? Okay, so here's something different. It says not Republicans, so what does that do to the probability?
Switches.
It switches it. So instead of being 0.3, it's now what? 0.7, right? So this one you could do it a couple different ways. If it's saying at least 7, that means the probability that x is less than or equal to 7. And then I can list out all of my.
Wouldn't it be greater than 7?
You can do it 2 different ways. You can do it where at least 7 are not Republicans, or you could say greater than, like greater than or more than 2 of them are Republican, like less than or equal to.
When you switch it.
Yeah, you can switch the probability. So I'm going to show you by switching the probability. And then the other way will work as well. So if it says at least 7 is less than or equal to 7, so you would do binom CDF 10.7 and 6.
Why wouldn't that equal 100 if you add what you did in the first problem?
Why not?
Do what?
Why wouldn't what we found in the previous problem and the one we're finding right now equal 100? Because if you're switching it, shouldn't it equal 100?
They won't. So if it says at least 7, oh, that's what I did wrong. I was confused. Okay.
Yeah, okay.
If it says at least 7, I'm sorry.
Seven or more.
It's greater than or equal to 7. So I want to include this upper range right here. I want to include this upper range right here.
Okay,
No.
can you change it to at
So
most?
10 is
Hold on. Let me do it this way. Hold on. Let me do it this way. Okay. So if I want to include an upper range, you have to think that the whole thing adds up to 100%, right? Or 1. And so if I find the probability of 6 and below, and I subtract that from 100%, I am left with 7, 8, 9, 10. Because binom CDF only does less than or equal to probabilities. So CDF only does less than or equal to probabilities. So when you have a greater than, like that, you have to do 1 minus. So I have to do 1 minus binom CDF of 6 and below. Okay? 6 and below. So it would be 10.76. So let me explain that one more time. When you have a greater than or equal to, CDF only does less than or equal to. So if you have a greater than, then you have to do 1 minus. So I'm taking the probability of 0 through 10, which is 100%, and I'm subtracting away 6 and below, and then that leaves me with 7, 8, 9, and 10. Another way you could do it is if you did binom PDF of 7 plus 8 plus 9 plus 10. So if you're like really, really unsure, and I promise you this gets easier with practice, but if you're unsure, then doing the binom CDF or PDF of 7, 8, 9, 10 also works every time. So I put a 6 here because I want to find this probability of 6, everything below, and I want to subtract it away, so it leaves me with 7, 8, 9, 10. So when I do 1 minus binom CDF 10, I said 0.7 because it said not Republican, and then 6, you end up getting 0.6496. Does that make sense? Kind of.
Not really.
You just have to think about it.
Yeah. It's just a lot of thinking. Okay, this is if it said how many Republicans would you expect and what is the standard deviation. You are just using the formula. So n times p and square root of np1 minus p. So you're just inputting into the formula. If it ever, and it'll just ask you for the mean and standard deviation. It won't ask you in a tricky way.
How do you know it's binomial when you look at this? You have to check with the
It has to check those properties. So it has to have 2 outcomes, has to be independent, has to have a fixed number of trials. Then you wouldn't proceed with the problem. It'll always be one of the 2 that I'm about to show you, like geometric or binomial. Okay, so you are deciding which one is which and which formula to use. Okay, the next one, this is where it gets really fun. It says, what is the probability that it is within 1 standard deviation of the mean? So in the last example, we had mean is 3 and standard deviation is 1.45. So if it's within 1 standard deviation, that means I'm going to add and I'm going to subtract 1 standard deviation from the mean. So it's saying what is the probability that it's between 1.55 and 4.55. But what's something that you know about 4.5? You can't have decimals when you're doing binom PDF or CDFs. They always have to be whole numbers. So if I had this on a number line like this, 1.55, 4.45, and I've got my 3 in the middle, you will always take your outside bounds and you will round inward, okay? So I'm going to round up to 2 and I'm going to round down to 4. So I'm going to always round inward, and it's basically saying what is the probability that it's between 2 and 4. Because when you get your decimals, like when I'm within 1 standard deviation, I get a decimal. And then it's saying what is the probability that it's within 1 standard deviation. You can't use the decimals, but you want to round inward, okay? So the smallest one goes up, the biggest one goes down. And I want to find the probability that it's 2, 3, or 4. So I could do 2 things. I could do binom PDF of 2 plus 3 plus 4. Or when I list out all of my outcomes, I've got 0, 1, 2, 3, 4, 5, 6, all the way to 10. I want to include these 3 right here. I could write it like this, and I'm gonna write it up here for you, and then I want you to kind of just think about it for a minute. Tell me what you think. So okay. So this is one way to write it. So think about it for a minute. So one way to get a middle range is to take the binom of your biggest value. So if I want to include 4, 3, and 2, this first one right here, this represents 0, 1, 2, 3, 4. Are we good with that? But now I want to subtract away 0 and 1. And I'm left with 2, 3, and 4. Another way to do this is binom PDF of 2 plus binom PDF of 3 plus binom PDF of 4. So I'm going to reiterate that every time, because if that's the way that you prefer, then you are more than welcome to do that. I find this way easier, however, it's because this concept of subtracting away the 1 and below like makes sense in my head. So sometimes it takes a little while to get there for that concept to click. Yes?
If you added all the individual binom PDFs for the last digit of the 3-digit sequence, would you put 1 because it's one number, or would you put the actual number?
You would put 2, 3. So it would be PDF of, whoops, that's the highlighter. It would be PDF, and then this number right here would be 2, 3, and 4.
Separately?
Are you talking about this number?
Uh-huh.
Yeah, you would put 2 and then 3 and 4. So you would have,
encompass the 1 and 0 still though?
if you, not if you did PDF.
Oh.
Yeah, yeah. That's, so the difference is you'd have to do a PDF instead of a CDF. Does that kind of make sense? Okay. So some properties, we're not going to do this activity. I'm very sorry.
Wait, Miss Arnold,
Yes.
for the last one, why are we including 1.55?
We're not including those because we can't put decimals into a binom CDF. So we always round inward to the nearest whole number. So the lower bound goes up and then the upper bound goes down.
So even if it's 1.1.
Yeah. Even if it were 1.9, like if my upper bound were 1.999, it would go down to 1. If my lower bound were 1.01, it would go up to 2. Yes. No matter what, we don't use the traditional rounding. We always round inward. So I usually draw a number line because that helps me. Okay, the last thing that we'll talk about today are the properties of binomial distributions. So this graph right here, you can kind of see, this is what I would have you do in this activity. It's going from, and this is what is happening when so imagine, scenario, I'm increasing the number of trials. I'm increasing the number of trials. This is what is happening.
Whoa.
I'm not increasing the number of trials. I'm increasing the probability. So right here, my probability of success is like 0.10. So I have a 10% chance of making a basketball goal. Or I have a 10% chance of making an A on the test. Something like that. This is, as my probability of success is increasing,
Taking more tests.
this right here would be 90% of success.
Probability of us failing.
So as your probability of success increases, the things I want you to memorize, I don't know if this is written down on your paper, is it?
I don't think so.
Okay, then write this down. You must memorize this.
Wait, where is this?
The whole PowerPoint's not in here.
Yeah. It's
Oh, okay, then write this down. As your probability of success increases, so if I'm going from probability of 10% to 90%, my distribution is changing from right skew to left skew, and it becomes symmetrical at 0.5. The next thing I want you to write is I'll upload like a chart with this on Canvas or something, if that will be helpful. Okay,
Actually, somewhere in here.
I'm gonna either watch this video later.
maybe. Also, as the probability of success increases, the mean increases, which makes sense because mean is n times p. So if my p is 0.1 or my p is 0.9, 0.9 is going to be greater. The standard deviation increases to 0.5, then decreases.
Is that for every case?
Just for all binomial. So what I'll upload on Canvas will be a T-chart comparing
T.
binomial and geometric distributions and how the probabilities change. So those two things, please memorize.